Lesson 4-5, Powers of Binomials. We're going to look at powers of binomials and binomial expansion. So in binomial expansion of a minus b to the nth power, there are n plus 1 terms. So we're going to be looking at Pascal's triangle, and I'll show you that in a little bit of while. But there are n plus 1 terms. N is the exponent of a and in the first term, and b in the last term. So really, you're raising n to both terms inside here. In successive terms, which just means in one term and then the one right after it and then the one after that. The exponent of a decreases by 1 and the exponent of b increases by 1. For example, if I had a to the fourth minus, let's say, b to the, just say I had a to the fourth. Actually, no, I'll just do a minus b, and we're saying we're raising this to the third power. This means the first term would be a cubed b to the 0 power. The next one would be a squared b to the first, then it would be plus a b squared, and then the last one would be a to the 0 b to the third. All the terms have to add up to whatever n is. So if n right here is 3, all of the exponents have to add up to 3, which they do. But my a's are decreasing by 1. The exponents on a is decreasing by 1, and the exponents in b are increasing by 1. So if I were to simplify it, this is a cubed plus a squared b to the first plus a b squared plus b cubed, because a to the 0 power is just 1, so it would be 1 times b cubed. That's what they refer to in here. The sum of the exponents in each term is n, so that's what I was referring to. All these have to add the same number, which is right here. The coefficients are symmetric, and that's where we're going to get our Pascal's triangle, which I'll show to you very soon. Pascal's triangle is just a triangle of numbers in which a row represents the coefficients of an expanded binomial a minus b to the nth power. Each row begins and ends with 1. And each coefficient can be found by adding the two coefficients above it in the previous row. So instead of writing out the rows of Pascal's triangle, you can use the binomial theorem to expand a binomial. The binomial theorem uses combinations to calculate the coefficients of the binomial expansion. So here is Pascal's triangle. This is just part of it. It continues further, but you can get the general idea. So you start with a plus b to the 0 power. That's anything to the 0 power is 1. Then if I do, so this would be row 0. This is row 1. Okay, so anything to the first power, that would be a to the first plus b to the first. Because really you're having a to the first, b to the 0, and then it's going to be plus a to the 0, b to the first, which will end up being 1a plus 1b. This next one, row 2, you have the exponent as 2, so this would be a squared b 0 plus a b plus a to the 0, b to the second, and we would have this becomes 1, this becomes 1, so there's your a squared plus ab plus b squared. Now if you're trying to figure out the numbers in front, if you're only looking at the numbers in front, here's a 1, 1, and 1. In between 1 and 1 here is a 2. That's how you get your 2, and everything on the sides are 1s. Start with a 1, add the previous 2, that gives you your 3. Here is your 3, and then you end up with a 1. And then you start with 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then you end up with 1. So you have, it's symmetric. So if I cut this in half, they're the same on both sides. So binomial expansion. If n is a natural number, then a minus b to the nth power would equal, and here's your combination, n choose 0, a to the nth, b to the 0, and then n choose 1, a to the n minus 1, and so forth. So you can use the combination function on your calculator to do that, or you can use Pascal's triangle to come up with the coefficients. The variables are pretty easy to solve, but it's the coefficients that can be kind of hard with it. So our first example, it says use Pascal's triangle to expand x plus y to the 7th power. So if I were to come up with the terms, I would have x to the 7th, y to the 0. Then I would have plus x to the 6th, y to the 1st, plus x to the 5th, y to the 2nd, plus x to the 4th, y to the 3rd, plus x to the 3rd, y to the 4th, plus x squared, y to the 5th, plus x to the 1st, y to the 6th, plus x to the 0, y to the 7th. Now I just have to put my coefficients, and if I use the Pascal's triangle for it, I use row 7, and row 7 is right here. I just put the coefficients in front, so there was a 1, a 7, 21, 35, 35, 21, 7, and 1. So my final answer would be x to the 7th plus 7x to the 6th y plus 21x to the 5th y squared plus 35x to the 4th y cubed plus 35x to the 3rd y to the 4th plus 21x squared y to the 5th plus 7x y to the 6th plus y to the 7th. So it's going to be a very long answer. The bigger the exponent, the longer your answer is going to be. But you can see using Pascal's triangle makes the math a lot easier. You're just worried about making sure the exponents on the variables add up to 7. Next, use Pascal's triangle to expand this one. So we're going to have very similar. So I'm going to do a to the 8th, and then it's going to be a to the 7th, b, a to the 3rd, or a to the 6th, b squared, a to the 5th, b cubed, a to the 4th, b to the 4th, a to the 3rd, b to the 5th. Then we got a to the 2nd, b to the 6th, a, b to the 7th, and then b to the 8th. Then if I use Pascal's triangle, if I go back to the previous one, if I add these, so this is 1, so we got 8, 28, 56, 70, 56, 28, 8, and 1. So it'll be 1 plus 28, and we had 56, 70, 56 plus 70 plus 56 plus 28 plus, is there 2 70s in there? 28. Okay, we got 1. I forgot the 8 here, so these are off just a tad. So this would be 1, 8 plus 28a plus 56 plus 70 plus 56 plus 28 plus 8, and then this is plus 1. And there would be our expansion. Otherwise, you're going to have to do a plus b times a plus b, do that 8 times, and that would take you a lot longer than doing the expansion here. Next, let's do this expansion here. So we have to use row 4. So if we did it very quickly, this would be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, so 0, row 0, 1, 2, 3. So this is row 4. So these are our coefficients we're going to use. So I'm going to have 1 c to the 4th plus 4 c cubed d plus 6 c squared d squared plus 4 c squared, or c d cubed plus 1 d to the 4th. And there's my expansion. My c's are decreasing by 1s and my d's are increasing by 1s. Just knowing that the first d is 0. Next, use binomial theorem. In 2016, the Chicago Cubs won the World Series for the first time in 108 years. During the regular season, the Cubs played the Atlanta Braves 6 times, winning 3 games and losing 3 games. If the Cubs were as likely to win as lose, which means they were 50-50, same number of wins as the same number of losses, find the probability that this outcome by expanding W plus L to the 6th power. For this one, to have 3 wins and 3 losses, I know it's going to be W cubed, L cubed. That's the term that we're going to be looking at. So we need to know what is the coefficient in front of that specific term. But in order to do that, I need to find out how many games there were, how many win-loss combinations were there. So to do that, do the binary expansion, we're going to have to add up all the coefficients on those. So to find the coefficients, I can show you on your calculator for this one. When we do this, this is going to be, we're going to choose the total number of, so the total number is 6 times, so that's our first number, so 6, choose, and then it's always whatever the second exponent is going to be of the second term. This would be 6, choose 3. If I go to my calculator and do 6 math, go over to probability, number 3, the NCR, that's choose, and hit 3, the coefficient is 20. So I'm looking at 20 W cubed L cubed. That's the term I'm going to look at. So that's my numerator, because when you do probability, it's the probable, like the likelihood, the outcome that you're looking for versus divided by the total amount of outcomes that they're going to be. So I need to find out the total number of win-loss combinations there are. So if this is 6, choose 3, I'm going to start with 6, choose 0, plus 6, choose 1, plus 6, 6, choose 2, plus 6, choose 3, and so forth. So to do that on a calculator, let's do that. So here we got 6 math, choose 3, and then we have a 0, enter, plus, you're going to do 6 math, choose, this will be 1, enter, plus 6 math, choose 2. Oh, I gotta go back to that. Math, we're going to choose number 3, and it's going to be a 2 plus 6 math, choose 3 plus 6 math, choose, we did 3, so now we got 4 plus 6 math, choose, we got 5 plus 6 math, choose 6, and then if I hit enter, I get 64. So there are a total of 64 games. So out of the 64, 20 of them is what we want to look at. So we have to find the probability of 20 out of 64. If I did 20 divided by 64, we end up with 0.31. So as a percent, if we did to the nearest percent, we would say this is about 31%. So about 31% of the time, they had a 50-50 win-loss record. Next, pizzeria sells about the same number of hand-tossed and thin crust pizza. The probability that the next 5 pizzas ordered include 4 hand-tossed and 1 thin crust by expanding h plus t to the fifth, round to the nearest percent if necessary. So we need to have, so a hand-tossed has to be 4, and the thin crust has to be 1. So if I did 5 choose, it's got to match the t, so 1. 5 choose 1. This is my numerator, and the denominator, I have to add up all of the coefficients for the whole binary expansion. So I'm going to grab my calculator again. We're going to do this all at once. So we're going to do 5 math choose at 0 plus 5 math choose 1 plus 5 math choose 2 plus 5 math choose 3 plus 5 math choose 4 plus 5 math choose, we had 4, now we have 5. Now if I hit enter, I get 32. So now we have, so down here is 32, but let's do math 5 choose 1. So 5 math choose 1, and that gives us 5. So instead of here, I'm just going to put a 5 here. So 5 divided by 32. 5 divided by 32 gives us 0.156. If I multiply that by 100, to the nearest percent with this one, we would have 16%, so roughly 16%. Next, a group of 8 contestants are selected from the audience of a television game show. If there are an equal number of men and women in the audience, find the probability of the contestants being 5 women, 3 men by expanding W plus M to the 8th, round to the nearest percent as necessary. So I need to do 8, choose 3, because I'm looking for W to the 5th, M to the 3rd, and this has to match up with this second exponent. If I go to my calculator, do 8 math choose 3, this will give us 56. So this gives us 56. I now have to find down here, so I'm going to do 8 choose 0 plus 8 choose 1 plus, and continue on. I'll do that. So we got 8 math choose 0 plus 8 math, choose 1 plus 8 math, choose 2 plus 8 math, choose 3 plus 8 math, choose 4 plus 8 math, choose 5 plus 8 math, choose 6 plus 8 math, choose 7 plus 8 math, choose, and we had 7, so now we have 8. Add them up, and that gives us 256. So now I do 56 divided by 256, multiply that by 100. The nearest percent, that would be about 22%. So it is time consuming, but the quicker you do it, or the more times you do it, the quicker it does. Or you can use Pascal's triangle to just add up those coefficients. For example 3, expand this one. So the difference here is the coefficients aren't 1 anymore. Okay, so that means we are going to have to get a bigger coefficient in front. Okay, so for this one, if I were to expand this, I'm going to have 4 choose 0, and then I have 2c to the fourth, 6d. I'm going to put a minus, it's a negative 6d to 0 plus 4 choose 1, and then this would be 2c to the third, negative 6d to the second, or not second, first, plus 4 choose 2, 2c squared, negative 6d to the second, and we have plus 4 choose 3, 2c and negative 6d to the third. And then our last one is plus, let me put that over here, so plus 4 choose 4, and then it's just going to be negative 6d to the fourth. Okay, now if I were to put these down on my calculator, I would have 4 choose 0 is 1. So 1 times 2 to the fourth power is 16, c to the fourth, plus 4 choose 1. 4 choose 1 is 4, times 2 cubed. 2 cubed is 8. Choose 3 times negative 6d plus 4 math choose 3, or math choose 2 is 6. So 6 times 2 squared is 4. C squared, negative 6 squared is 36. D squared plus 4 math choose 3, that gives us 4. So 4 times 2 to the first power is 2c times negative 6 cubed is 200, negative 216. And this would be d to the third. And then we have 4 choose 4, which is 1. So that would be plus 1. And then negative 6 to the fourth power, negative 6 raised to the fourth power is 1,296. And then this would be d to the fourth. So now my answer, I have to do 1 times 16 gives us 16. So 16 c to the fourth. So this one is done. Next one I have 4 times 8 times negative 6. That gives us a minus 192 c to the third D. So this term is finished. I'm going to use a different color for each term so we know what we're doing. Now the next one I have 6 times 4 times 36 gives us a positive 864 c squared d squared. Next one, I have 4 times 2 times negative 216 gives us a minus 1,728 c d cubed. Then our next one, this one we got 1 times 1,296 and I forgot a 2 here, so times 2 as well. So times 2. Actually, no, not that one. That one is not times 2. So this would have been a minus negative 6 to the 4th power and 1,296. So 1 times 1,296, this will give us a plus 1,296 d to the 4th. That would be my answer for that question. And our last one here, expand it to five terms here. So write this down. We have 5 choose 0, and this would be 2x to the 5th. I'm not going to put the negative 3y to the 0 because that's just 1. Plus 5 choose 1, 2x to the 1st, negative 3y to the, actually this is 2x to the 4th, and this would be to the 1st. Then we have plus 5 choose 2, 2x to the 3rd, negative 3y squared, plus 5 choose 3, 2x squared, negative 3y to the 3rd, plus 5 choose 4, the 2x times negative 3y to the 4th. And the last one would be 5 choose 5, and we just have negative 3y to the 5th. Okay, so for this first one, 5 choose 0 is 1. 2 to the 5th, 2 to the 5th is 32. So 32 times 1 is 32. X to the 5th. Next one here, we have 5 choose 1, which will give us 5, times 2 to the 4th power is 80, times negative 3 to the 1st power is times negative 3, gives us negative 240, so minus 240, x to the 4th, y. This one would be 5 choose 2, gives us 10. 2 cubed is 8, so times 8, 10 times 8 is 80, times negative 3 squared, that's 9, so times 9 gives us 720, so plus 720, x to the 3rd, y squared. Next one here, we have 5 choose 3 is 10. Multiply that by 2 squared, which is 4, times negative 3 cubed is negative 27. Gives us negative 1,080. This would be x squared, y cubed. Next one here, we would have 5 math choose 4, which is 5. 5 times 2 is 10, times negative 3 to the 4th power is 81. Gives us 810. 810 x, y to the 4th. And our last one here, 5 choose 5 as 1. Negative 3 raised to the 5th power is negative 243. So this would be a minus 243 y to the 5th. And that would be our answer. That's our lesson on powers of binomials.